G'day everyone. So I've rebuilt my crank, and in today's video I'm going to take you through the process of how I did that. So I'll start off by saying I'm not a mechanic, nor do I claim to be, but having said that, I am pretty confident with the result that I got. It's got all new bearings, the dimensions are correct, and it's true to within factory spec, so I'm pretty confident that once it goes back in the bike I'll have no problems. Now, to get this done in the home workshop, I did need to make a few purchases. The most major one being a 20-ton press. So this one cost me about $300, and for a cheap Chinese press, I'm pretty happy with it. Got the job done. There's a dial gauge for truing the crank. I think that cost me about $100. And on top of that, I also needed to build a few stands and jigs. All right, so there's the pressing jig. All this is a piece of steel pipe. This is 5mm wall, 150mm internal diameter, I think. And that slot cut out of the side there is just to create clearance for the con rods. There's also a pressing plate, which is a piece of 10mm steel plate with a notch taken out of it. Now that notch needs to be big enough to go over the big ends of the con rods, and you'll see how I use that throughout the video. There's also a slightly smaller plate which we can use in conjunction with this one, and that one is specifically for taking off the cam sprocket. Alright, there's the alignment jig. All this is a piece of 50mm angle with a piece of flat bar welded to the bottom of it, and I mount this in the vise and use it to line up the flywheels on the crank when I'm reassembling it. Alright, then we've got the truing jig. The base of the truing jig is a piece of 10mm plate steel, and that's just to give something for the magnetic base of the dial gauge to mount to. There's a piece of 25mm square bar and a piece of angle iron mounted to the top of that, and that angle iron is what we use to support the two center bearings of the crank on. And we use this to measure the run out of the crank once we've reassembled it. So it definitely wasn't a cheap operation rebuilding this crank. I think all up, parts and tools cost me about $11.50. But having said that, to get someone else to do it was going to cost me $12. So for slightly less money, I got the job done quicker. I got to collect more tools, which is always great. And I got to expand my skill set. So despite being out of pocket nearly $1,200, I'm still pretty happy. Right, so I've got the parts in the mail this morning, and the first thing I'm going to do is put the crank pins back in. So these are the new conrod kits. They come with a crank pin, 2 bearing plates, a big end bearing, and the conrod. So we want these in the inner flywheels. So I reckon I'll just get it started with the copper hammer and then I'll put it in the press. Let's give this a crack. Don't know whether I've gone a little bit too far there. Time will tell. Alright, so the next thing I want to do is press these 2 halves together. Before I do that, obviously I need to put the bearings on. This side is the side that the cam sprocket goes on, and it has to align with a little notch here in the other flywheel. Now the book says not to do this unless you have an alignment tool, but I've got another idea of how I can actually use this to line it up on that and press the whole thing together at once. So we'll see how that goes. First things first, we'll get the bearing on this side. So first there's a washer. And then we just need to get the bearings started. Alright, so what I reckon we'll do, so this is a 360 crank, so both crank pins need to line up with each other. I'll see if I can just line this sprocket up with that notch, hold it there, and then line up the spline like so. And then we'll just get that sprocket started on there. Right, so washer, bearing, sprocket, other bearing race, just so I don't forget it. Right end facing down. Other flywheel with washer, inner bearing and circlip. So now I'll just line everything up. Make make sure that sprocket's lining up. Oh, God damn it. Can't see. That's lined up. She's pretty much there. Alright, so I think I won that battle. The sprocket's all lined up. Alright, so I don't know if I should be doing this or not, but I'm going to use a bit of grease inside this race to stick the rollers in, because they're not captive. They've just given me a bag of rollers, which is a real pain in the ass, because every time like you slightly tap it, they all fall out. So I'm just going to use a little bit of grease so they just kind of stay in place, and hopefully that'll solve my problem. So I've made up this jig to make sure the flywheels are aligned before I press them together. I've got the crank pin at 90 degrees to the jig itself, because if it does misalign, it's going to do it in one of those two directions, because it can't move this way or that way because it's on the pin. So I'll pop that at 90 degrees. We'll get that in there. Then I'm just going to start it with a hammer. Probably would have been better the other way around. That would have been smarter. So I'll make sure that's aligned. That's pretty good. Alright, so in the shop manual it says to press both flywheels down until the total width between the machined faces is 68 millimeters. The pin is 65 millimeters, so depending on how wide that is, I could press this all the way down till they're only 65 apart. I don't want to do that, so what I've got, so I have these two washers, and together they're 3 mil, so 65 plus 3 is 68. I'll put one washer on each end of the pin, and that way I can just press it down as hard as I want and it's never going to go any further than 68 mil. I'll put the thick one on the bottom. Well, that's that one. And I'll drop this one in here. Oh, that's as far as it wants to go. There's a fair bit of movement in there. Alright, so my plan worked. It's actually 67 millimeters, so it's a mil less than what the book ordered. But the book's for an XS1B. And I'm thinking they probably had different con rods, because the amount of side play in this is insane. Like, that's just not cool. So I think I'm just going to have to press it right down until they contact and hope for the best. Alright, so I ran into a bit of a problem when I pressed the last flywheels together. When I did this one, and pressed it all the way down onto the pin. The con rod's nice and free to move. However, this side locked it right up. I then pressed it apart a little bit, but the press that I've got just doesn't have the precision. So when you put the pressure on, it'll build and it'll build, and then it'll move in one big jump. So after a bit more research on the internet, I've found the dimensions for the later model cranks, or for the later model bikes, and it is 66 millimeters between the machined faces on each flywheel set, 54 millimeters between each flywheel set. So this side is actually bang on 66, so that's bloody lucky. Just out of curiosity, I'll just measure the side clearance on the con rod. So it's bigger than 0.3 of a mil. And smaller than 0.6, so that means it's in spec for what the XS1B manual says. So I'm happy with that anyway. The distance between them is like 54.2 millimeters. I'm not pulling this thing apart. I'll get away with the 0.2 millimeters, I reckon. And this side is 55.6. So I've got to spread that another 0.4. I'll just give it one pump and see how it goes. See if I can save myself a bit of time. I'll measure it on here. Alright, that didn't move. We'll try 3. One. That actually felt like it moved a little bit. Alright, so after a lot of stuffing around, I've got my dimensions sorted. This side is 65.9 millimeters. I'm not going to argue with that 0.1 of a millimeter because I don't think I'm going to get it any better. Alright, so now to true up the crank, what I'm going to do is I'm going to support the 2 center bearings on this V block here. Make sure that's free to spin. And it's nice and stable. Alright, from there what we can do is take a dial gauge, place it on there, and then we can see how far off centre it is. Alright, so now what we're going to do is we'll rotate it, and you can see the needle's moving between about 70 and 15, which means it's 0.55 millimeters out around or off center. So we'll get it at its highest point. and we'll put a chalk mark there on the outer flywheel. Then we'll take it out of the jig, support it on something, and then hit it really hard with a hammer to try and knock it straight. Alright, so you'll notice I have a copper hammer. You don't want to hit this thing with anything hard because then you'll dent the flywheels, and we don't want to damage those. So the chalk mark's here, which means this is the high point, so we want to knock that down in relation to the crank pin. Then we'll put that back in the jig and see how it went. Alright, so that's gotten a bit better. We'll just repeat that process until we get it as close as we can. Alright, so that was a lot of toing and froing in between the jig and the floor, and this is my hammer now. It's definitely seen better days, but I think we're there. There we go. And that's within 0.02 of a millimeter. Alright guys, so that's probably the most complicated part of the rebuild out the way now. I'm pretty happy with the result. I've learned something new, and I'm tooled up to rebuild XS650 cranks now, which is a great thing because I've got another one just over there which I'm building for my dad. So I hope you got something out of this video. If you did, please leave a like and a comment, and I'll see you in the next one.